Hi everyone, I am going to go over some of the different ways to classify matter. We have here some images that are to model some of the different ways that we can classify matter. So the first thing to remember is that we can classify matter as either a mixture or a pure substance. When we classify something as a mixture, that means that we can physically separate it, perhaps by evaporation or maybe by distillation or a filter or even something as simple as picking it out with a tweezer. When we have a pure substance, that means that the material is already in its simplest atomic form, and in order to separate anything, we'd have to actually break apart atoms. So mixtures, we can classify a mixture as either being homogeneous or heterogeneous. With a homogeneous mixture, we cannot see the different materials. So a good example would be salt water. We don't see the salt dissolved in the water. It's simply that the salt is now dissolved, which means that the atoms, the molecules, are spread out so much that we can't see them. They're very, very tiny. They're no longer in their big crystal chunks. So that's a homogeneous mixture. When we have a heterogeneous mixture, that means that we can see the particles. So perhaps mixing some sand and gravel together. I can see the different components and I can pick them apart. Now, a pure substance can be divided into two different types of substances. Pure substances can be classified as an element, which would be found on the periodic table and is in the simplest form, or it can be classified as a compound. Now, a compound is going to be two different elements bonded together and always in the same proportion. So, like water, H2O, there are always two hydrogen atoms bonded to one oxygen atom in water. So take a moment and see if you can classify these 5 different images appropriately. Pause it and then come back and I will go over the correct answers. So A is a pure substance that is an element. We can see individual atoms, and so that would be an element. Letter B, you can see all the different parts of the mixture, and they're different, so we would label that as a heterogeneous mixture. For letter F, we would call this a pure substance that is a compound. The reason it's a compound is because we have two different elements here bonded to each other. And then finally, G is heterogeneous and H is a pure substance. I would say that when we have an image, we kind of have to call it heterogeneous because we can see the different parts. But I could see an argument for G being homogeneous if you were to talk about how there's an equal amount of suns and X out signs and saying that they're equal amounts. And so maybe if we had this in the laboratory, we couldn't see the separate components and we could call it homogeneous. And then finally, the last one is a pure substance that is an element, just like for letter A. Now that you have a basic idea, take a minute and pause this before I go over it and see if you can label all of these different things appropriately. So pause this for a moment and then come back and I will go over it. So part 1 says to classify the following as homogeneous or heterogeneous. So all of A through F on this first part are all mixtures. If we have a pail of sand and water, we would be able to see the sand. So we would call this heterogeneous. Letter B, when we look at the air, we can't see all the different things in the air. There's more than just oxygen. There's oxygen, there's nitrogen, there's carbon dioxide. We can't see all of those different things, so we would call it a homogeneous mixture. Human blood, kind of the same thing. When you bleed, we don't see all the different parts. You've got red blood cells, white blood cells, platelets. That would be a homogeneous mixture. Letter D, a banana split. I can see the bananas, I can see the ice cream, I can see the cherries. That's going to make it heterogeneous. Chocolate syrup has water in it, has sugar in it, has dye in it. We can't see all those different things, so that's going to be a homogeneous mixture. And seawater. When you go out into the ocean, you actually can see a lot of stuff floating in the water. Most of the time you can't see to the bottom when you get pretty deep. And so that seawater has all kinds of stuff floating in it. Salt, perhaps even eggs from other organisms, many microscopic algae. So that is going to be a heterogeneous mixture because we can see all the stuff floating in it. If we look at the next set, we're going to classify those as either an element or a compound. The key with determining if it is an element or a compound is the number of capital letters that we see in the formula. Each element always has a symbol with one capital letter. So if I look at benzene for letter A, I can see that I have a capital C and a capital H. Capital C stands for carbon, capital H stands for hydrogen. I have two different elements bonded together here, so that's going to be a compound. Letter B, aluminum. The symbol for aluminum is a capital A with a lowercase l. The capital A, I have just one capital letter, so that helps me identify that I just have one element in this formula. Aluminum would be an element. Letter C, if you look at the formula for aspirin, you can see that we've got carbon, hydrogen, and oxygen. So we have three different elements within that formula. Therefore, that is going to be a compound. Letter D, titanium. The symbol for titanium is a capital T with a lowercase I. Again, every symbol of an element will have one capital letter in it. So if we look at the symbol for titanium, we can see that there's just one capital letter. This is just one single element. Letter E, the formula for acetylene is capital C, 2, and capital H2. So we can see again that we've got two different elements there. So that is going to be a compound. And letter F, zinc, the symbol is capital Z with a lowercase n. We've got one capital letter in this symbol, and that helps us identify that this is just a single element. Finally, the last set of 6 says to determine if it is a pure substance or a mixture. So again, recall that a pure substance has to be either an element or a compound. When we have mixtures, we have many things within that mixture. So salt water, A, is going to be made up of water and salt. That is going to be a mixture because we have several different pure substances within it. Letter B, isopropyl alcohol, we can see the formula there. That's going to be an indication for us that that's a compound, which means it's a pure substance. Letter C, mercury, we can see that it has just a symbol of capital H, lowercase g, so that's going to be an element, which means it's a pure substance. Letter D, ammonia, we can see 2 capital letters in that formula. So remember that that's going to be a compound, and compounds are going to be classified as a pure substance. Letter E, an egg yolk. Now, if you think about an egg yolk, you probably think, oh, there must be a lot of different stuff in there, which is true. You've got protein in there, you've got fats in there, all kinds of different compounds. So that is going to be considered a mixture. And the same goes for honey. Honey's got a lot of different compounds mixed all into it. Some sugars, some water in it, so many different things. So that would be classified as a mixture.